Welcome to Biology My Passion. I am Soumya Harikrishna. We are now learning the chapter Work and Energy. In the first video, we learned all the aspects of work. In the second part, we discussed the questions related to work. Now let's discuss the second part of this lesson, that is energy. We are all familiar with the word energy. We know we use energy. But have we seen it? No, we can't see energy, but we can do work using energy. Let's see some examples. Suppose you are touching a mango on a tree with a stone. Nothing happens to that mango. But if you are throwing the stone over the mango, targeting it, it will detach from the tree. So initially it was not doing any work, now it is doing some work. Second, if there is a nail, I have to drive into the wall. If I keep the nail, I just touch with a hammer, doesn't work. If I take the hammer out and hit it, then the nail will drive into the wall. The same way, if a bus is stopped, you can even lean on the bus and stand, no problem. But the moment the bus starts moving, we jump out of the way. In all these cases, what happened? Once they started moving, they got the ability to do work. So, the ability to do work in physics is called energy. So, the amount of work done is equal to the amount of energy present in it. When we are doing work, we are utilizing energy. So, when more energy an object has, more work it can do. And if less energy a body possesses, less energy, less work it can do. Work is a scalar quantity, we know. Energy is also a scalar quantity. And what is the unit of energy? Unit of work is joule. So unit of energy is also joule because energy is the ability to do work. 1 joule of energy is defined as the amount of energy required or utilized for doing 1 joule of work. For example, if I am doing or I am using 100 joule of work is done in moving an object from one place to the other, then what is the amount of energy I used? 100 joule. Okay, so work and joule are equal in this case. Now when we want to express it in bigger terms, we use a bigger quantity called a kilojoule also. So 1000, kilo means 1000 joule is 1 kilojoule. Now coming to different forms of energy. We are familiar with the different forms of energy. Chemical energy, like coal, petroleum and all these natural gases, they have chemical energy in them. When we burn, we get that energy. That's why we use them as fuels. Or electrical energy. We have different means to produce electrical energy. Or there is nuclear energy. There is wind energy. Hydrothermal energy. Sound energy. You know, when something is vibrating, it possesses sound energy. Light energy. Who has light energy? Mainly the source is sun. Sun has light energy. Magnetic energy is there. But we are talking about something called the mechanical energy. So mechanical energy can be of two types. One is called the kinetic energy, second is called the potential energy. Let's now discuss in detail kinetic energy. Let's come back to the examples we took in the beginning. The stone which we threw on the mango, or the hammer we hit on the nail, or a moving bus. In all these cases, only when they started moving, they could do work. That means by moving, they attain the energy to do work. For example, if you, in that case, we can say kinetic energy is the energy possessed by moving body. That means by virtue of its motion, they possess their energy to do work. So when they were still, they couldn't do work, but when they were moving, they could do work. The other examples we can say the flowing water has got kinetic energy. As a result, it can rotate windmill, but stagnant water cannot do that. The same way, the flowing water's energy is used for hydroelectric electricity. Or when we are talking about a windmill, it can rotate the blades only when the wind is moving. So that also it is possessing kinetic energy. Or when we are firing a bullet from a gun. So the bullet has got moving energy which will help them to do the work to pierce through the target. Okay, so all these energy means by virtue of its motion, this is called a kinetic energy. So now we have to learn the formula of kinetic energy. Let's see how to derive the formula of kinetic energy. We are considering a mass of m moving with a velocity v. So we know that it has to do a work equal to the velocity. Here kinetic energy of this body will be equal to the work done in attaining this velocity v. For example, this is the initial position A, and what is the initial velocity? It is still, it is not moving, it is stationary. So the initial velocity u is considered as 0. Now we are moving it or applying for work done, is that is force is applied, so it is reaching the point B, attaining a velocity v. And let's take the acceleration produced by body as a and the distance covered as s. So now according to law of motion we have the equation v square minus u square is equal to 2as. So v square is u square is 0 here, so v square is equal to 2as. So here we can see displacement, if how much it is displaced, s is equal to v square by 2a. According to Newton's second law of motion, force is equal to m into a. So here the work done in moving the object is, we know, force into displacement. So if you substitute as force as m into a, into displacement we found v square by 2a. So a will get cancelled. So what we have, m v square by 2, this can be written as 1 by 2 mv square. So this is the formula of kinetic energy. Kinetic energy possessed by a body is half mv square. That means kinetic energy of a body is directly proportional to its mass provided v is constant. We are not changing the v. Or kinetic energy is directly proportional to the square of the velocity if mass remains same. So according to the formula Ke is equal to half mv square, we learned that Ke is directly proportional to m. Or double the mass, kinetic energy also becomes double. Right? The same way, if we half the mass, Ke also becomes half. So when it is coming to velocity, Ke is proportional to v square. So here if I increase velocity, doubles the velocity, provided mass is the same, then Ke, how many times it will become? 4 times. Because 2 square it is 4. V square becomes 2v square, right? So it is 4. The same way, if you half the velocity, then kinetic energy becomes 1/4. It will reduce to 1/4. Okay, so this relationship you have to remember. So let's see a small example. How is kinetic energy is affected if mass is tripled? So without doing, we know that it is going to be 3 times because it is directly proportional. But how to solve it? Ke is equal to half mv square. The initial one we can take as 1, and second condition, mass is tripled, so I write 1 by 2 3m into v square. So now we have to find out the relation Ke2 by Ke1. So 1 by 2 3 mv square by 1 by 2 mv square. So all these common factors will go. So Ke2 is equal to 3 Ke1. So the relationship is 1:3 we can say, or it is 3 times of the first one, tripled. The second type of mechanical energy we have to study is potential energy. Potential energy is by virtue of its position. So the energy possessed by an object by virtue of its position, raised position, that means above the ground level. Whichever object is above the ground level, it has a potential energy or change in its configuration. So this one, when it is by raised position, we can call it as gravitational potential energy, and this change in configuration we can call it as elastic potential energy. So potential energy, basically 2 types are there: gravitational potential energy or elastic potential energy. See, if this pen is lying on the ground, it does not have energy. But when I am picking it up from the floor, I am doing some work in order to bring it up to a height. So that body will possess energy. That energy is the potential energy of the body. The more I lift up, the more energy it possesses. For example, we keep dams or reservoirs at the top high altitude region. Means from there, when it falls down only, it has potential energy. The same way, if I keep this pen here, nothing happens. But if the same pen, if falls from the roof and falls on my head, it really hurts. Or if I am falling here, nothing much will happen. But if the fall is from a height or building, then definitely it's very dangerous. So why in each case this is happening? The more we raise above the ground level, the more energy the object possesses. So the body has that energy, that is called a gravitational potential energy. Now coming to the second one, elastic potential energy. Here the energy is possessed by overcoming the elasticity. There we are doing some work to overcome the elasticity of the object. For example, if a spring is stretched, it has energy. Or a spring is compressed, it has energy. Here both the cases we are doing some work against this elasticity. Or a rubber band, you know that, you in classes, some of you naughty children, they do. That rubber band, they keep a small piece of paper and they throw it at someone. It will hit at the target. How does it possess that energy? So when you are pulling the rubber band, you are giving an energy to it by changing its configuration. That energy is against its elasticity. Or another example, you can say that when you are winding your watch, these days we have the automatic watch or electronic or smart watches, but the olden type you have to wind the watch. There we are coiling it tightly so that it possesses some energy. That is also potential energy. Or another good example is a bow. When you are targeting the arrow at a bow, you cannot simply give it. You have to stretch maximum to target it at a distant object. So when you are pulling it back, you are giving it some potential energy against its elasticity. Okay, so these are the two types. Now let's derive the equation of potential energy. Let's see the derivation of the formula for potential energy. So suppose there is an object here on the ground. I am lifting it up to a height here. So initial position is A, this is B, and I raised it to a height of H. So when I want to lift it, I am doing some work on this object. So we can say in order to do work, we are applying force here, right? So the force is considered here as mg because it is done against the gravity, mass into acceleration due to gravity. Then what is the displacement? S here is h. So work done, we know the formula is F into S. So here if you do the substitute the value mgh. So potential energy is equal to mgh. So from this formula we can see that potential energy is directly proportional to mass of the body. Potential energy is directly proportional to acceleration due to gravity. Potential energy is directly proportional to the distance at which it is raised. So all these are directly proportional. So if you increase the mass, potential energy will increase. Potential energy is directly proportional to the acceleration due to gravity. It can change on different parts of the earth. The value of G is maximum at the poles and minimum at the equator. And if you increase the height also, the potential energy will increase. Questions and numericals related to these topics we will discuss in another video.